Welcome to the session. In this session, you will be learning about weld design in CATIA V5. Before going to weld design in CATIA V5, let's see what is this weld and why it is required and how it is used or created in drawing and how this weld design helps. Let's see. Whenever we create a component which is going to be welded or fabricated by using welding, so let's take a simple example. So we have a simple T-joint. Okay. So usually in many CAD software we just create these two features and we'll call it in assembly and we'll create the drawing. So in CATIA drawing workbench, so we have option called represent the fillet. So we'll be adding a fillet in assembly workbench, and then we'll be representing the what is the weld is all about, what kind of weld and what are the values and other things. And to avoid this, to make simple in the drawing creation, the software developer created the workbench for weld design itself. So we can create this weld in 3D itself, and then this can be represented in drawing very easily. And moreover, it's very important in any product, what is the nominal weight of the total product. See, this information we can represent in the drawing, but what is the weld material, what is the weight of weld is added to the particular product, we cannot come to know in the drawing. So it is good to have a 3D component or 3D representation in the software, and we can measure that nominal weight. So what is the approximate weight? We cannot measure the actual is actual, but at least to nominal value we can calculate by this weld design. Let's see how to represent weld symbol in CATIA drawing, and then we'll come back to the workbench and see the weld design. Let's open CATIA. So we have simple T structure, so two components. Let's go to mechanical design, drafting. So let's go with blank. So create the generate front view, window, product. Let's select this. So this is the view. We know that, so both the sides it will be welded. So to represent that weld, we have let me check where is the tool. So let's check in the insert. So under the annotation we have symbols, in that we have weld symbols. So we'll be using weld, so not weld symbols, weld. We want to represent the weld on the drawing. Just select this weld, and it's asking select the first edge. So this is my first edge, and select the second edge. So let me select this edge. So the weld as represented with the values. What are the values we want? We can define it. And here when you pull down this, we have different kinds of representation. Is that flat, concave, convex, and different kinds of weld. So let's see one by one later. So let's go with simple. So this, what happens when using this gives the clarity to the operator and what kind of weld it is. And let's add the simple weld symbol to this also. So just select the weld symbol, select the weld. So we'll make it none. So let's include the tail. This is just a simple fillet weld. So this is how we represent in the drawing. But by representing this, we'll not come to know what is the weight of the weld we are added to the product. So to help in this, CATIA has a different workbench called Weld design. So let's come CAT product, and when you come here, start menu, mechanical design, we have workbench called Weld design. When you open this Weld design, so we could see the different, so it's created new. Let me close this. So here we have already in the Weld design workbench. So we could see there are different types of welds are available here. Let's see how this works and what happens. So the first one is mode. So we'll leave this, we'll see later what is this mode. So we directly come to create weld on this product. How to create weld on this? So here we are going to create just fillet weld. Select the fillet weld, and we have parameters. So we have different parameters, and then type, we have material, and what is the connection, what is the annotation. So do you want to create annotation for the weld which we are going to create? If you say yes, we'll see what happens. So we have enabled, we want the weld symbol. So here there is one more, length always displayed. So let's see what is that length also. Under parameter, we have what is the name of the weld is just simple fillet weld, and height. So here we have what is the height of the weld. So what is the shape? So as we know that there are different shapes or the result from the weld, either it is flat, convex, concave or smooth. Let's have with the flat, we'll try with the flat, and there is something called first limit and second limit. We'll see that later. First we'll just create. So it's asking two surfaces, surface 1 and surface 2. Between two surfaces the fillet will be created. Let's choose, this is our first surface, this is our second surface, and click OK. So here there is some warning message. So new applicative property have been added. It means, can you come here, application. So we'll see annotation set. So there is an weld annotation is added, and then assembly joint as added. The system is computed by its own. Now let's see. So 5 mm is the weld, and the 50 is the weld length. And if you want to, so here there is no tail added to this. If you want to add the tail, so we can just enable this tail, and you can get, this is the complete representation of what weld we have created. So when we have this kind of information to the reader, you will get the clarity, what is the weld size and how long it is created, what type of weld they are going to use. This is the basic of weld design, and rest all other welds all be similar like this. So when we see this, so we see there are two more items added. One is material, the other one is specification. So those specifications are comes under here, and when we create drawing for this, so we'll take one more view. So go to drawing, create one more view. You can see the weld comes by default. We can do hatchings in the weld zone, so it will give the clarity to the reader or the operator. This is weld zone. So now what we have seen is fillet weld on the one corner. If you want to create fillet on both the sides, since it is T-joint, if you weld both sides, the strength will be more. So to do that, let me undo this, whatever we have done, and we'll try fillet weld on both the sides, double weld. So now the requirements are three items, three elements we have to pick. So what are those three elements? So first element, second surface, and this is my third surface, and rest all will keep as it is, and just check, click OK. So warning message. So the weld is created on both the side, and the symbol also created as per the weld. So this indicates both side weld, and both are 5 mm 5 mm. We have not defined the length. That's the reason we didn't get the length of the weld. Now let's see how to modify this weld. So here we can, when you expand this, the last node we have weld. Just double click on the weld. If you want to modify or change anything on this, now let's try. We'll go with convex. So as soon as we make convex, we got one more field, offset. So what is the offset we wanted? So let's make 0.5 or 1 mm. Let's click OK, and it's asking for update. Let's Control U. Now you see the shape is updated. So we have to be clear about what kind of weld we are going to do and what's the result we needed. Based on that, we can update the parameters. Now let's see the other value. There is something called trimming, first limit and second limit. What is this first limit and what happens? Let's try with 5 mm. What happens to this result? It's asking for update. Let's Control U. So you can see the weld is offsetted 5 mm from the one edge. And if you want this kind of trim on the either side, we can go with the second value also. Double click on the weld, and second limit also will modify to 5, and Control U. See, both things are updated, and now the weld length also updated. The total length is 50, so we offsetted 5, and now we got 40 on either side. So this we can vary only one, so both the sides will come same, since it is both double weld, and system adds its own limitation as well as, and this is the best from the weld design. I hope this gives you clarity how to make fillet weld in the weld design. Thank you. Now let's see how to create butt weld in weld design. So just we have the predefined object is there, and now let's see butt weld. So square butt weld. So select the square butt weld, and here we have 4 options. One is surface or edge or surfaces. So based on the selection, the result will change. First, let's go with surfaces. My first surface and the second surface. So between these two surfaces we want to build, and it's asking 2 more surfaces. So what is the 2 more surfaces? Top surface of the component. So now the weld is created between 2 pieces, and it has added the weld symbol as well as. So this is all about butt weld. Now let's see other butt weld with different shapes. Let me undo this. So we'll go with single V butt weld. So what is that single V? The shape of weld. So we can go with same. Now this time let's choose the edges. Earlier we have choose the surfaces. Now let's choose edge. I want to create on these 2 edges, between these 2 edges. So based on the selection, first selection, the selections will change. Earlier when we have used surface as the element, we have to pick 4 items. Now since we have choose the edges, the system will compute automatically. and the rest of the items are remain same. Let's click what is the result. So again the warning message, and now you can see so the weld symbol is created, and then you can see the shape of the weld and the shape of the component it has taken automatically. So when you want to move or modify this symbol, so we can just drag and it will come. This orientation can be changed by changing the annotation view. If you want to modify, we can modify. Let me check how to change this front view. So it's not happening. Now let's see what is the double V, double side. So let me undo this. Control Z. So for each item we have two things. One is one side and the other one is other side. So just let's see one example of V butt weld both side. Select the V butt, and now we have 6 elements of the input. Let's go with edges, so it will simplify our selection. So first edge and then second edge, and we'll go with third edge. This is my third, this is my fourth edge, and let's click OK. So again warning. You can see the shape is with double V, and 6.5 is the height of the weld. So it has created 6.5, 6.5 either side. If you want to change this, we can modify the parameters. That can be done in assembly joints, joint body and weld. So here we can play and make it the changes. So the height is 1 mm. That 1 mm is nothing but between two welds. So if we increase or decrease, the total length will change. So here you will have schematic diagram. What is this values is all about. A, B, C. We have what are the parameters you want to modify. You can modify and you will get the results. I think this session gives you clarity what is weld design is all about, and this weld design workbench has its own limitations. So here we could see only fillet and butt joints are available, but in reality, based on the complexity of the product, we may need different kind of welds. But for the moment, these are the things are available in the tool. You can explore. Wish you all the best. Thank you. Now let's see what is propagation in weld design. So let's select the simple butt weld, and then here we have a propagation mode. One is so we have with propagation and without propagation. So what it happens, first let's try with propagation, and it's asking for a surface and edges. So select the edge. We want to create these two edges. Now you see the component is, the shape of the component is as per the weld design, and so in this case only the change is going to happen in the one component, not on the blue color component. And let's change this propagation. So without propagation, just click and then update the weld. Let's control U. So you can see the design or the shape of the component is updated, only the length of the weld. The rest of the items are not made. Is this possible, or how we are going to communicate to the manufacturer or operator? So the operator should have the idea what kind of design we are doing and how we are representing it. So this is one more advantage using weld design in the product. What happens, the operator will come to know, or he has to prepare this shape. So let's hide the weld design. So this has to be made before making it, so otherwise we cannot get this kind of joint. So while welding, the welder or the weld will just fill the material, but this shape has to be attained before going to weld. So the operator will get the clarity what is the design is all about, and are we helping him, or is this feasible for him to do. So this, as a designer, we are the responsible to give the sufficient information to the operator in the model and in the drawing. So this gives the clarity of what is the propagation with propagation and without propagation in weld design. Thank you.